Hi guys. In today's procedural guide, we intend to simulate the ice splash water simulation. In my previous tutorial, I did just the water splash simulation. You know, as a product animator or a beginner product animator, to become a very good animator, you must upgrade your skills back to back, upgrade it from just a mere basic skill, gain deeper knowledge, gain deeper experience within the field, understand the expectation of your clients, and always practice. Stay updated, stay creative, don't stop learning, and above all, be patient. So, I believe you already have your model, which are the cup and the ice. So, if you don't know how to model a cup or the ice, kindly install Blender Kit on your machine or on your system. Blender Kit is a free add-on that houses over 20,000 free free models that that you can use even without having a license to. They are all free. You don't have to pay for any subscription. So I got this cup and the ice from my Blender Kit. If you don't know how to install Blender Kit, I would advise you to check out other YouTube videos that can guide you through how to install Blender Kit. So let's get right into it. So the first thing we'll do here is we will duplicate the cup. So after duplicating the cup, we scale it up. So you scale it up. This new cup is going to be bigger and thicker than the one we want to use. So immediately after that, you go to your scene collection and you hide the bigger cup. You don't just hide it from your viewport, you also hide it in your render option. So your render option is the camera sign that you disable. You can see the right of disable in renders, and here is just to disable or hide in viewport. It's just a temporary thing for the viewport, but in the render menu, it won't come out in your final project. So, without wasting much of your time, you click on Shift A. You go to your mesh and you branch out at the UV sphere. So the first thing you do so that you won't forget is you right click and you activate the shade smooth menu. You scale it down. After scaling it down, you drag it up. Okay. So what's the next thing? So we go back to the hidden cup. I think we start all our modification from the hidden cup. While on the hidden cup, you go to the physics properties of the hidden cup and you move straight down to the rigid body. So rigid body, you make it passive. And for the collision shape, you make it mesh. Reason for making it mesh is such that when the cube drops, it won't drop at the surface. It will drop at the bottom of the cup. What's next? Okay. So we repeat the same process for the cup we can see. So we'll go to rigid body, we click on active, and for the collision shape, we branch out to mesh. All right. What's the next thing? Okay. For the cube as well, we go to the rigid body. Yes, active. That's all. For the cube, make it active at the rigid body. That's all. Go to the second cube, also active. You leave it for now. So for the cube, you go back to the physics properties. You click on fluid while you hide your rigid body. So for the fluid, you change the fluid type to the effector. Effector type, you make it collision such that there will be a very good interaction with the cup. So that there will be a very good interaction with not just the cup as well as the liquid. And you can also make it planar. Okay. And you move to the second cube. You repeat the same process. Go to the fluid modification. You make it effector. And here you also activate this planar. Yeah. So what's the next thing to do? What's the next thing? Okay. Yeah. Okay. Now, before we proceed with the cup, let's create our liquid domain. So a very fast way to create the liquid domain is to click on F3. F3 is a shortcut, and as soon as you click on F3, you see all these options on your screen. Then you type quick effects. So quick effects, you branch out to quick liquids. And if you are not so familiar with the use of shortcuts in the Blender interface, you click on the option menu and you scroll down to your quick effects. You see the same option, which is quick liquids. But either ways, I believe you understand what I mean. So here is our domain. You scale up the domain. Don't let the domain be too small, and don't let it be too big. Just make it moderate. Okay. I believe this measurement is okay. Yeah, I believe this measurement is okay. So what's the next thing we do? The first thing we do here is we scale up the resolution of the liquid. The default resolution is always on 32, so you can scale it up to 100. It depends on the processor speed of your system. So if you like this demonstration so far, don't forget to like, share, and subscribe. And if you find it difficult to understand any of the demonstration, I would advise you to pause or rewind or you play back. And don't just watch. As I am doing this thing, this is a procedural guide. So as I'm doing this demonstration, I also expect you on the other side, on the other tab, to be reciprocating the same thing. And with the expectation that your result will be same as mine. So immediately after that, you move to your scene properties. So at your scene properties, At your scene properties, you go to your rigid body world. You open up your your uh, your cache, your catch, or whatever pronunciation you call it. So before you decide when to end the simulation, we advise you see what happens. Okay. You can see the behavior of the cup, which means there was a mistake. So we have to go back and check where the error lies. So we'll go back to our physics properties. We check the rigid body, you see? So where the error lies for the cup here is, instead of me to change the rigid body type to passive, I left it as active. So please don't ever make that mistake. So now let's see the result. Okay. As you can see, the behavior is different. Okay. So let's cross check. Yes, let's cross check the hidden cup. Yes, the hidden cup, the rigid body is also the rigid body type is also in passive. So we go back. We go back to our domain. We go back to our domain. Okay. Yes, before we go to our domain, we click on this cup. You go to fluid. We check out the fluid option. So we readjust. If you could remember, I've already adjusted the fluid option, but I feel the creation of my liquid domain overrode, whichever way you understand it, the instruction I gave to the cup. So I will have to repeat that same process all over. So that is what I'm doing now. So for the fluid type, we make the cup an effector. And surface thickness, we make the surface thickness 3. Reason for upscaling the surface thickness is such that the liquid will not flow through the cup. So we repeat that same process for the hidden cup. We also make it our effector, and we go to the surface thickness. For the surface thickness, we also upscale it to 3. All right, and don't forget to always save your file. So let me just call it glass. Let me just GL, yeah. It's always important you save your file intermittently. Whenever it comes to your mind to save, always save. Just click on Ctrl X. So it gives you the privilege to save. So what's the next thing to do? Okay, we go back to our liquid domain. Go back to our liquid domain. And don't forget, any adjustment made, you must always rebake. You must freehold and rebake so that it can take effect. Yeah. So I almost forgot something. You go back to your sphere. Liquid type. Yeah, it's good. It's on flow. Okay, liquid, the type, flow. Flow type, liquid, of course, yes. And for the flow behavior, the flow behavior by default is always geometry. So you change it to inflow. When you change it to inflow, it's going to drip out like water coming out from the tap. But if you leave it as geometry, it's going to take that same shape of the sphere and drop into the cup, which might not give you the kind of expectation that you hope to get. Okay, so after that, we go back to our domain. Okay, for the fractional obstacle, by default, the fractional obstacle is always 0.05. You scale it down to just 0. So reason for adjusting the fractional obstacle is so that so that the liquid can have a better a better interaction with the glass cup. So the simulation type is on replay, so we make it whole, and we activate is resumable. The activation, our bid to activate this resumable is such that even if at all the Blender application crash, we won't lose our big file. So what do we do now? Should we bake now? Should we bake now? Or we should bake the scene? Okay. I feel we should first bake the rigid body scene. So don't forget, to do this, you go to your scene property. You bake. So this baking only affects the cube. So you come back to the physics property and you scroll down. Don't forget to always mark your mesh. So the up-res factor is 2. You can scale it up to 4, depending on how you want it. Okay. So now, decor. Baking is done. Let's see what it looks like. Okay. You can see it's beginning to overflow. No problem. So I think there is a way to control the liquid. Okay, let's take a look at it once more. Okay. So take it back to frame or frame. Let's take it back to frame 40. Yes. So at frame 40, we will stop the liquid. So how do we get that job done? So go to your liquid, which is the sphere, and you have the option. There is something called flow behavior. Immediately after the flow behavior, there is a use flow. So around the use flow, you set a keyframe. Yeah, that's how to set a keyframe. Very simple. So you move to the next keyframe here. You press 42. You unmark the use flow and you put another keyframe. So the instruction that you give your Blender application, this is the effect here. These are orange logo. So let's see it again. Let's see if the instruction we gave worked. Okay, that instruction didn't work simply because yet to free. We are yet to free the bake option. So, like I said, any modification done to the liquid domain, you must always rebake. Like you can't escape it. So we'll come back here once more. Press free hull, and let's end the simulation at let's say 80. So we bake all again. I had to scale down the simulation time to end at 80. Initially it was 250. So let's see the liquid behavior. Oh yeah, I think that's perfect, but it could be better. Okay. I think I have to freehold once more and make it 150. But what I was trying to achieve, I've gotten it already. So the main reason for scaling it up to 150 this time around is to have a better user experience. If you noticed, as soon as I got to frame 80, it started all over again. I wouldn't want it to look that way. The bake is done. The modification has been made. Don't forget, initially we were on 250 here. We baked. I didn't like the interaction. I scaled it down to 80. The interaction was not favorable. Then I decided to scale it up to 150. So let's go back and see what it looks like. Okay. Yeah. I think this is fair enough. So let's reduce our keyframe, our timeline, I mean, to 150. Oh yeah, I think this is perfect. So an adjustment should be made on the cube such that the rigid body behavior and the liquid domain behavior won't be executed at the same time. More or less like when the water is done dripping, then the cube will drop. So the water stops dripping around, I think, 80. So we can decide to excuse me, we can decide to set the keyframe for the rigid body at 100 or 101. So go back to our cube. Click on the first cube. You set the keyframe to 100. That's on the timeline. And you close the fluid simulation so that you won't tamper with it. We go to rigid body. So at the rigid body settings, the mass should be left at 1 kg. And well, we can reduce the mass. Maybe we can make the mass 0.5, yes. And at the dynamic option, you unmark the dynamic, then you set the keyframe. You move to 101, press enter, you mark the dynamic option again, and you set the keyframe. So that behavior gives you this orange notification that you can see here. So let's see what that looks like. Okay, so it has been modified already, but then it looks like we have to rebake. So let me repeat the same process for the second one. So move to 101, keyframe 101, you remove the dynamic, you set the keyframe, then you move your timeline to 102, you set the keyframe. Yes. So we go back to our liquid domain once more. Yes. Okay, before then, go to our sim properties. Okay, our sim properties has been baked. Delete the bake and rebake again. Okay, yes. I think I just got the final result. Back in my mind, I was actually thinking I will have to go to the liquid domain, free hall, like liquid domain, go to the physics property of the liquid domain, free hall, and rebake. But a better way to adjust the modification of the rigid body is to go to the property scene or the scene property. The scene property the catch option. You can see if you want to delete bake or you want to free haul or you want to bake again. So that is where you bake. You bake the rigid body simulation at the same property while you bake your liquid domain at the physics property. Please keep that in mind. And if you like this demonstration, don't forget to like, share, and subscribe. So